Okay, so I'm hoping to get a project proposal from everybody today. I'm assuming you've worked on it, yeah? Um, so we need to talk about how do we begin a design based on that project proposal. One of the things that happens, right, is we're trying to follow some sort of a process that lets us go from this cloud, right, this uncertainty, and eventually up here we have, at the end of next semester, we have a concrete product. One of the things that a lot of companies do is they want to have traceability. They want to know, why are we doing this? There he is, Jack. So they want to know why they're doing things. So that's why you write everything down. You write down the concept of operations. Hello. You write down the requirements. You write down the architecture. So there should be a thread. That up here we've got, for example, the product has a battery, right? And we decided that it was a, I don't know, a 5 milliamp hour source. You know as well as I do that 5 milliamp hours isn't going to get you much, right? So we made a mistake. We got to here and we made a mistake. What you want to be able to do is trace that mistake back and figure out, oh, we got our requirements wrong. Or, oh, we got our high-level design wrong. The aim is to try and not make that mistake again. So that's called traceability, and there's a variety of tools that you can do that with. The big one that UTC used to use was a thing called DAWS that was eventually part of IBM. And it was just a database that allowed you to write documents and put in pictures and that sort of stuff. But everything you put in there had a number, and you couldn't change that number. That's why Word is the greatest thing for requirements, because as soon as you put in a new requirement, the numbering all changes. Right? Whereas here, you want to be able to go through the whole project and have that traceability. Why did we do this? And when I did this, I ran the DAWS database for a couple of projects in UTC. And sometimes, up here, I had an email from the VP of Engineering. Because the only reason I could find we were doing one particular thing was because the VP of Engineering sent an email to the team. You want to know that motivation. You want to know why you're doing it. It even gets to the point down here, you're writing code. And sometimes, and often, the code that's there is satisfying a requirement, and you want to know which requirement it's satisfying, right? Why am I writing this code? And traceability helps that. So one of the things I would like to see, and in the project proposal, is that your requirements are numbered and not using Word. Right? I think you had the, what was the acronym? MAGIC? I've forgotten what the, is that right? So use the numbering scheme Magic 1, Magic 2, Magic 3. Right? That way you know what. Now, it may be that for some reason you decide you're not going to do Magic 2. That's okay. Well, no, you delete Magic 2 and you add Magic 10 or Magic 2A or whatever the, right? You cannot reuse the numbering. Change it like arrow. Yeah, I mean, yeah, that's okay. Oh, sure. I mean, I'm just making that up as I go along, right? You can do that whatever you want. If you've got a better name for the project, use something related to the name of the project. Yeah, I mean, I think I told you the one of the projects I worked on at UTC, all of the new product projects were called special projects, and then they were given a number. So the thing I was working on was called SP14, Special Project 14. Then once we started getting some traction, um, we got marketing on board and decided what they were going to call it. And then we got the name or the acronym NGP, or Next Generation Panel. Right, so we started using NGP. But all of our initial requirements were SP14. Not sure what you mean by pixel panel. No, this is combination access control and intrusion detection, or burglar alarm. So it could run these doors, or swipes, and there's an embedded Linux device that could control up to about 128 doors and various other peripherals for access control. Plus it was certified for reporting back to Central Station, which is where if you have a monitored burglar alarm, there's usually there's a standard that lets you report alarms, fire, ambulance, and police alarms back. Not into the doorknob, but there's a computer system. Usually it would be mounted in the wall, and there'd be like a button like that, or a pin pad that lets you call the cops. Like it'd be like this, but there would be usually they had we had three buttons: fire, police, and ambulance. Well, that's what Central Station's about. If it's monitored, then it's not going directly to the emergency services. You get somebody to call in from the monitoring centre, and they'll determine whether the police or fire or ambulance need to be sent. That's one of the biggest problems in burglar alarms, is false alarms. We did a big what do you call it, study of all the alarm calls going into the Chubb Toronto Central Station. There are about 200,000 of them, I think, over a couple of years, and we found that about 99.6% of them were false alarms. Right? It's just crazy. Yeah, it was just ridiculous. NGP. Yeah, they're the so when you go to emergency services, they're usually the three options. You usually only go to the one. If you dial 911, they're the three options, right? That's yeah. So it could go locally, like there could be a security guard on site, so it could go to them. If there's no security guard on site, it'll go to Central Station, which is the monitoring centre, and then they'll try and they'll try and call the premises, but at the same time they'll also call the key holder, the person who's nominated to be on call if something goes wrong. Yeah. Yeah. So yeah. So that's one thing I would like to try and do. So that's where we are. There's three things left to do. The written proposal for the team is due tonight, and then for the end of semester we need to have the preliminary design document and the presentation. Now, Daryl Stein is going to be taking you next semester, and I'm going to see if I can get him along to your presentation so he'll know what to expect next semester. Okay. So the project proposal is still a little bit nebulous, right? The next document, the preliminary design, should be much more about what are you actually going to build. And there's lots of ways to think about what you're going to build. This is one acronym that you may want to think through. It's done by Peter Marks, the reference down the bottom there, right? And he had the acronym Dollar Appeals, right? And the acronym stands for availability, right? How is the product or process provided? Are you going to sell it online? Is it going to be a service? Is it going to be a product? What's it actually going to, how's it going to be made available to the customer? Packaging. What's it going to look like? How big is it? How much does it weigh? What's its physical form? What's the performance parameters? What are the cross-functional requirements? How much does it weigh? How long does it last? How much can it lift? How easy is it to use? Right? Does somebody need to have a 3-hour training session to use it, or can they just start playing with it and it's obvious what to do? A friend of mine who writes software has always had made the statement that if you're explaining, you're losing. Right? If you've got an app that you have to explain, then it's too complicated. It's losing if it's not clear from the get-go how the app is supposed to work, then that's losing. Right? Okay. Assurances. So this is if you're actually going to put the thing to market. How long is it going to last? Who's going to fix it when it goes wrong? What comeback does the customer have? And costs. So the total non-first cost of ownership. So this is once you've got the thing, you've paid for it separately. How much does it cost to run? Do you need power to run it? How much does that cost? Do you need to replace parts? How much does that cost? What are the maintenance costs? And social acceptance. Right? I don't know if you remember a few years ago, Google came out with their Google glasses, right? And that was socially unacceptable to a, yeah, it's got with there's I think Snap I think are coming out with some spectacles now that do some. Hmm? Haven't seen the Facebook one there. Oh, did they? Yeah. But again, it's when Google Glass came out, right? The people who were wearing the Google Glass were called glass holes. Glass holes, right? Because um, yeah, friends of mine, because it was voice activated, but it wasn't the person's voice that activated, it was any voice. So a friend of mine used to find these people and say, "Hey Google, call mom," and have the Google Glass call the person's mother. No, he suggested some other things that were not the right thing. So yes, but no, that was one of the more family-friendly versions of what he suggested they do. And then the last thing is total first cost. So what does it cost to buy up front? So one of the interesting things about UTC is, well, it's no longer UTC, it's Raytheon. One of their business units is Pratt & Whitney aircraft engines. And they lose a lot of money on selling their engines. They don't recoup the manufacturing cost in what they charge when they sell their engines. Where they make money is on the maintenance. Right? So if all they made, if the only money that came in was what their customers paid, what Boeing and Airbus and those sorts of people paid for the engines, they'd lose. It's once you start having to maintain the engines that they make a lot of, that's where they make their money. That's where a lot of their profit comes from. I don't know what the split is now, but it certainly used to be the case that the maintenance operation was much bigger. Okay, so something to think about. As I said with the traceability thing, one of the things you want to do is know why you're doing something. right? And sometimes you've got to make a decision between two or more options. A way to capture why you're making the decision is in something like this. It's called a Pew Chart, right? And what you do is across the top here, or for each column, you have all of your options. And you select one of them to be your baseline, right? So there's your baseline. That's your default selection. And it scores 0. And then you have the points of comparison, right? Criteria 1, 2, 3, 4, 5, however many. Usually these are performance related. And you check their value. And then you say, okay, for option 1, is it better or worse on criterion 1 than the baseline? And in this case, it's better, so they put a plus in there. For option 2, is it better or worse? Put a plus, it's better. For option 3, it's worse on criterion 1. Then do criterion 2, 3, 4, 5. And then at the end of it, you write down the effect of all the pluses and minuses. Right, for option 1, it says it's no better or worse than the baseline. Option 3, it's slightly better than the baseline. Option 2 looks like it's significantly better than the baseline. Right? And what this is doing is it's communicating why we're going to choose option 2. It's not making the decision for you. Even with this information, you could still decide to stay with the baseline. But then you've got to come up with a reason why that baseline is better than the 3 pluses. Maybe you left out a criterion that's overarching. Right, that option 2 just doesn't meet at all, ever. And the product must meet that one. In that case, you've got to rethink your options, right? But the idea is you want to communicate. The place I use this is that NGP panel. We were trying to decide what operating system to use. And the options, we decided our baseline was Linux. At the time, there was an embedded thing called Windows CE. There was an OS called Green Hills. And I've forgotten the other one. There was another one. What's it called? It's the one that the Mars rover used. I've forgotten what it was called. And so we did that, and we wrote down what our criteria were. Our criteria were, I've forgotten all of them, but team knowledge, right? And we already had team knowledge of Linux, particularly embedded drivers. We didn't have, so the Windows CE was a minus because we didn't have anybody who'd actually done work on an embedded Windows device. It was I think we had a 0 for Green Hills because we had some people who'd used Green Hills before. We had a minus for what's it called? It's on the tip of my tongue. Another thing that was in here was legal. right? Because Wind River, that's it, yeah. Thank you. And there was cost. But I had to work closely with legal on our project to get everything in place. And it turned out that the lawyer I was working with had worked for Otis on another UTC business unit at the time. And he'd worked on their new elevator controller. And the new elevator controller was to use Windows CE. And we weren't quite so strict about safety. Otis, elevators kill people if they don't do the right thing. So Otis is very, very concerned with safety. And Microsoft made some statements about Windows CE that were not true, that impacted the safety of the device. And so Otis pulled out of the contract with Microsoft. Microsoft sued them, and it was a complete debacle. So our legal team didn't want to go that way. Also the cost. In fact, it was, most people think Linux is free. Well, no. Certainly Windows was more expensive, but our management wanted us to engage. There's a lot of Linux, embedded Linux contractors, and they wanted us to engage with one of them to have backup in case the team couldn't do stuff. So it wasn't zero cost for Linux, but it was certainly less than what it would cost to get the licenses, because each Windows CE license I think was going to be about $5 a device on top of anything else. So it was going to be well, it is now. I don't believe so. I don't believe so. Anyway, but the aim here is you want to express your what your decision is, and it's your decision. You're not saying this chart told us to do that. The chart didn't tell you to do it. If you have another reason for going for option 1 or option 3, you do it, but you explain why you're doing it. Right? This is the aim of the chart, to be able to explain why you're choosing option 2 over the baseline or something else. Okay? So I probably shouldn't put this in because it's more relevant for next semester. Every week I like the team to tell me whether everything's going good, there's a problem, or we're crashing and burning. Right? So I like to have a traffic light system to say what's happening. What I did, I wonder if I can find that. That might be interesting to see. Did I have it here? Maybe I didn't. There we go. Right, so what I did, I'm expecting to see a project plan, right, in your project proposal. And I'm hoping Daryl's going to keep you to that project plan. Now you need to replan, that's okay. But this is what I did for the teams last time. Right? 100% is the project is complete. And each week I got them to update their project plan to tell me where they were. And this dotted line is a projection, a linear fit to the numbers they were giving me. And this is a later one. They mostly finished. But nearly always, this is the end of semester. And this is where my linear fit was telling me everybody was going to finish. None of them did, no. Nope. I can think of maybe one. Yeah. Now, fully worked based on what you know now, right? And I'm not saying they didn't work, it's just based on what your expectation is now. So, try and plan it, but also try and plan or think about places you can downscope. Because when you're in this, it comes at you pretty quickly next semester. Try and figure out what's happening. Let's see if I can find an earlier one. Let's go back to here maybe. I don't know, I actually thought the parking automation was the closest. Yeah. Right, so here the fridge guys did a really good job early on, but then they struck a few technical glitches that meant they stopped making progress. See if I can find the video. Oh no. So I'll show you that's not what they meant by parking automation. I don't know whether I got NGP, Next Generation Panel. Um, hmm. Hmm. So, depends on the device. I can't get onto Blackboard for some reason. Oh well. Let's try pipeline. Try again. So the only thing the only battery ours required was to be able to. I think there was a 24-hour, had to stay up and running for 24 hours. So it had a little 12-volt lead acid battery in it. Well, there was only one per site usually. Yeah, there we go. There's the board. There's two. There's the base board and there's the SOM. This is the Linux machine, and then there was another micro controlling all the I/O. So we had yeah, yeah, from scratch. Yeah. So it was pretty complicated. Thankfully, I was working with a really good. In fact, the project lead was a really good hardware engineer. He did. He and a few other people did most of the hardware design. What do you mean, little these? Well, um, that's a microprocessor. I think those are memory. They were SSD memory. I've forgotten what these are. That looks like it's a controller for the SD card. Sorry, say that again. Yeah, the Carrier had a manufacturing plant down south, and we got these built in their manufacturing plant. I did mostly the software. The other parts of the team did the hardware. Yeah. These things. So there's lots of lettering on the box. These little square things, they're capacitors and resistors. They're surface mount capacitors and resistors. Um, this thing here. Most of the white stuff is lettering, but it's circling little. All of these things around the outside, they're RS 485 buses, so they're serial buses, and then so they need some protection and drivers and stuff. well, it's batteries aren't CMOS, but yes, it's a battery too. Yeah, exactly. Which one, the blue one or the white one? The blue's the capacitor, yeah. Um, I have forgotten what the white ones are. Yeah, I've forgotten. They may be. I know there was some resettable fuses on there. They may be resettable fuses, but I thought they were closer to the RS485s. I don't know whether this one does. This is from a third party. It was a while ago. The hmm, yeah, that was the panel. Okay, so what I was trying to do today was these, but I forgot that we need USB cable. Is some? Oh, do they? How long would it take if you wouldn't mind? So it uses that sort? Yeah. Okay, that'd be good. Thank you. How are we going to power them? USB. Oh, you can power it separately, but the USB powers it. Well, so you don't always want to program it, right? Sometimes you just want it to run. So you've got a separate power if you just want it to run. Yeah. Yeah, so hopefully we can get a cable. I should have remembered to bring one, but unfortunately I didn't. I know there were some around here, but I can't see them now. So while Chuck's getting that, I'm gonna try. Well, not as conceived in the first version, right? So, Okay, so I was hoping to here we go. Right, the right USB and all that sort of stuff. Yes. I was hoping I got a check my yep, just a screenshot. I think that was all I asked for. See what it says. We're just waiting for Chuck to come back. I forgot to bring some USB cables in for the Arduinos, and he said he might have some in his dorm room, so he's just gone back to try and see if that happens. But basically I just wanted to try and run something on one of the Arduinos. We used to have some cables in here, I thought, but can't see any of them now. So let's see if we can find some code for the Arduino Uno. Is there? We got some yep, Arduino looks good. Where's that? Sorry. I see. Oops. Okay, that's just making sure we can get some of the extra bells and whistles. I thought there used to be some. I thought there used to be any. You're right. I just can't see it there at the moment. it's just different. Yeah. Yeah. Yep. I mean, that's. I was wondering if we could just do a little LED or something. Hmm. Okay, so there's some code. Let's see if we can grab that. And let's see if we can format it a bit better, maybe. There we go. See if that compiles. And let's yeah, that seems to compile okay. In the sketch. Might be a different version or something. Now I'm just going to go and see if I can find an LED. Nope. Have a couple of those. No LEDs. Let's see if there's some over here. There's one. That'll do. I'll just steal that briefly. So where are we? Pin 13 is there. I've forgotten which way around we want to do the... Oh, that's why, because it's... Let's just see what it says about which way around it is. Yeah, that... I think we just need to put it... they're male. I couldn't... So I think we want that one to go to D13. So I think just gotta, keep forgetting which way around the LEDs are. So there we go, long LED. Long LED is the positive, that's what I thought. So basically we want to put that from there to ground, just like that. And that's all we need. And now we need a USB cable. Should have thought about it. I have a USB cable, but no, they didn't. I thought we have plenty of those in the lab, but I keep forgetting that I'm no longer allowed access to the lab, so let me just see if I can. Do you mind if I steal that? Sorry? Serial port not selected. Let's choose COM3. So that's, you had already programmed it to do that, had you? Okay, so that seems to be doing the right thing. Let's just make it flash a bit faster. There we go. Yeah, so that's programming it. So Chuck, did you get a cable? You got a couple of cables? Okay. So try that. I'll get you an LED. Julio, you can oh. Now, where did I think I saw it there. So if you can't do it on your laptop, the Arduino should be available on the what's that? Oh, yeah. Yes, I got the I think I got yeah, there it is, Arduino. Got it installed, so you should be alright. The long line goes into pin 13 and the short line goes onto the ground beside it. Right, so there's the ground beside it. So I'm just putting the LED in there. And it looks like that's what it does by default. So try doing that code. I can show you the website where I got it from. Try changing the LED flash rate. So learningaboutelectronics.com, let me just post that. Here, maybe? Yeah, long lead in pin 13 and short lead underground beside it. Yeah, let's have a look, Jack. You got it? Yeah, I think by default it has that flashing setup, but try and I just sent the link out as an announcement in Blackboard, so you should be able to download the code from there. I shall return. I'm just going to go to the bathroom quickly. It's run.
You said that there's an announcement.
Ah, so I should get rid of that one, shouldn't I? Basically down here. So grab that code there. Now, is it connected? Let's just check to see which one it's connected to. Arduino Uno is the one. So that programmed, and now it's flashing. And then I just wanted to speed it up a bit to check that it is actually programming. And now it's flashing faster. But try and get it flashing faster. So under announcements, and you've got to scroll down. This one's too long. I should delete it or something. Yeah. So scroll down a bit, and there's a code block. Yeah, there it is. Just cut and paste that code block in. What are you going to reset? Yeah, I just cut and paste code, do something different. I just wanted to get something done. Yeah, exactly. Let's see what that does. It should make it quite slow. Oh, you're going to make it very slow. I'm not going to wait that long. So that should be... So that just compiled it. To download it, you need to press the arrow beside the check mark. Right, it's going to be up for, what, 100 seconds? Is that 100,000? It's 100,000 milliseconds. So that's... Yeah, maybe that, if you don't want to wait around for, what's that, 2 minutes 40 every time. Okay. So let's just have a look at that code and see what it's doing. And I actually recommend not using the Arduino IDE, but that's a whole other... Right, so the first thing, the I/O on the Arduino is general purpose I/O. Right, that means you can tell it whether it's an input or an output. And the first thing, the setup there says set number 13 to be an output. So that configures the pin. And then all it's doing, the loop in Arduino code is just starts at the top and goes down, and then starts at the top and goes down, unless there's some other thing that stops it doing that. And it just writes out a high to the LED, then just waits for 250 milliseconds as far as my code's concerned. Then it writes a low to the LED. These outputs are just digital, so you can only go, well, this particular output's just digital, so it's only high or low. I believe there are some other ones that are analog output. Yeah, they're digital. The analog is analog inputs. Yeah, I think the only way you can get an analog output out of this is doing something like PWM, pulse width modulation, to synthesize a particular voltage. So did you manage to... You did change it. Yeah, very good. So the nice thing about Arduinos is that they've got no other operating system getting in the way, right? So they can deal with stuff in what I'd call close to hard real time. If you've got an operating system like Linux or Windows or the Green Hills one or Wind River's not too bad because they actually do like doing real time stuff. but Linux generally and Windows, unless it's the really good embedded one, which is a new version, they get in the way of doing real-time stuff. So things get delayed because the operating system is off doing other things. Okay, so wanted to do that briefly anyway, even if it's only a taste of it, just so that you can see. Now let's go back to this class. Right, so I think we've at least done that one and maybe also half of that one. We haven't actually looked at the RPi yet, so I'll only do half of that one. Yeah. That NGP device, we had it all. You saw it was NGP 3320, I think was the number. They had 3320, 2220, various numbers in between. The 2220 was a downscaled version, but it was only downscaled because we disabled lots of the I/O. It was exactly the same hardware as the high-end system, but all you had to do is load up a certificate file, a registration file, and it would change what it had available. And we did that with a little embedded web server on the device. So you could change the licensing on the fly if you wanted to. So yeah, these things you can certainly do. You can certainly do a web server on them. Oh, sorry. Yes, sorry. These ones don't have. I'm thinking of. I wrote a little web server on something similar, but it has a Wi-Fi shield. This one needs a Wi-Fi shield to be able to go on the network. Depends on what you're getting it to do, right? Sure, it's going to slow down. Right? That's why you you generally use a bigger server if you depending on the load. But one thing you do with this stuff is you set up the website and then you load it and you increase the load and you increase the load and you see what happens when it falls, because it will fall over eventually. Well, so what I mean by load is the number of people who are. So there's a thing called JMeter. Apache JMeter. That is a Java system program that'll allow you to run to load websites, right? And you can set up the URL that it's going to call. You can set up what it's going to do with the URL, and it'll. What it does is it lets you set up multiple processes doing the same thing. So you can pretend to be 10 users or 20 users or 100 users to see how long it. Well, usually what happens is it doesn't fall over, it just takes longer and longer to respond to each request. And you check the response rate. Whether there we go. So this is the sort of stuff. What you can do is here I ramped up the number of users. The y-axis here is the number of users, and then I kept the number of users at 100 for a while. It ramped up after 30 seconds to 100 users, and then it kept that way for about a minute, and then it ramped down to 0 over 10 seconds. And then this was my take a number website, yeah. So then this is the number of transactions per second, right? And it's only doing about 6 or 7 transactions a second. And then this is what happens with the response time, right? What do you mean, what's up with it? So this is my this is this website, and the transaction is hitting that take a number button, because that's a transaction is something that changes the website, right? So that's what that transaction was doing. I was calling pretending to push that button up to 7 times a second to see what the and then that's what happened. As I ramped up the number of users, it the response time went out to about 50 seconds. Right. Yeah. No, it refreshes automatically. Oh no. Yes, but my app has expired. I need to rebuild it. But I have an app that shows me that I need to serve customer number 90, and shows me how many customers are waiting. Right, so it does this sort of stuff. It tells me I need to serve number 6, and there's currently 1 customer waiting. And if once I've finished serving number 6, I click the green button and it goes on. And see if there's anything else there. I think that was about it. Yeah, that was a lower. That was only going up to 12. This is JMeter. Yeah, this is the output that JMeter gives you. Apache is the name of the organization. The tool is called JMeter. JMeter. Yep. It wants it's wanting to really heavily load a thing I built. And what I did is I set up a series of Amazon instances, and all the Amazon instance would do is and then start running JMeter pointed at the website I was trying to load. And I ended up I could only start up 20 Amazon instances at once, but my website, even though it had 20 servers, 20 other machines pointing at it to load it up. Worked out pretty well. web servers are better off on something like a laptop or a desktop. It depends on what you want to do with it, right? It's not going to be able to do a lot. There's not a lot of memory there, so you can't put a lot of images and all that sort of stuff. Why? What do you need to know about GitHub? I'm teaching some software stuff at New Haven, and that's the first thing in every class is get yourself a GitHub account if you don't already, and accept this assignment. GitHub Classroom is pretty nice. It lets me run tests. Sorry? Sorry, say that again? No? Yeah. See, I'm not sure. I think that the trouble with that is tools change. Like 10 years ago, I wouldn't have used GitHub. I would have used Subversion. And before that, I used Perforce. And before that, I used RCS. Right? I agree that some sort of version control should be taught, but I think it should be integrated into the rest of the course. That's why I try and get teams here to use it, right? Because it's it's just a good way of centrally storing everything and versioning it. It's going back to the traceability, right? When somebody makes a change, you want to know who made the change and why they made the change. GitHub lets you do that, or Git lets you do that. Yeah. So I'm interviewing at the moment for a few people, and one of the jobs required a technical test, and they said you can forgo the test if you have a GitHub repository we can have a look at. So I'm a moderator on one of the Stack Exchange sites, so the series of sites that Stack Overflow is part of. I'm a moderator on the signal processing Stack Exchange site. And every time I do a solution to questions on there, it's usually in MATLAB or R or Python, I put it up in my GitHub repository specifically for those solutions. So I just sent them the link to that, and that meant I didn't have to do their technical interview because they already know that I've got some background in that area. hmm Yeah, no, it's worthwhile doing. It's worthwhile learning about, I think. Sure. Nah. So there's two things, right? There's this one, and this is just a this is like my web page that, and GitHub tells you how to do all this, so you can do blog posts, or you can list publications, or you can have a resume. But my actual oops. So this is, you might remember about the CET466. Well, Matt will anyway. I don't know, Julio, did you do 466 with me, or have you not? Yeah, so you'll be taking it with Daryl next semester, I think, if you do. Yeah. Yeah, so this is my, yeah, this is my DSP one, right? Digital signal processing. It basically asks, it's like Stack Overflow, but it asks about signal processing, the sort of stuff you do in, what is it? Is it 346? Is that the where you Fourier transforms and all that sort of stuff? Hmm? What was I saying about 346? It's just the content in 346 leads to this stuff. Yeah. Right, so you probably look at frequency, maybe you talk about power spectral density, I don't know. And the follow on, the stuff you would do after 346, yeah. Well, you know Stack Overflow, yeah? So Stack Overflow is a question and answer site. You ask a question about software and somebody will try and answer it. This is similar idea. The Stack Exchange has, it's got stuff like religion and law and academia and all these other topics that similar Q&A sites, question and answer sites. This one is about signal processing. So it's about Fourier transforms and Z transforms and Laplace transforms and how you go about using those to do telecommunications and all that sort of stuff. So let's have a look at the tags, right? Image processing, MATLAB, FFTs, filters, discrete signals, Fourier transform, signal analysis, audio, digital comms, noise, filter design, continuous signals, finite impulse response, infinite impulse response, all sorts of stuff. Okay, is that okay, Chuck? I mean, oh, they're not yours? Okay. Free? Yeah. Well, keep them. If that's okay, if that's okay, sounds good. So let's leave it there.